My name is Greg Wolfson. I'm the Chief Technology Officer for EcsoSmart Solution. So one of the attributes, a very critical attribute of geothermal exchange, which is the technology we're using, is that it is inherently extreme climate resilient or resilient to extreme climate events. And there's no magic to that. It's geothermal, it's underground, so it's protected from anything that happens on the surface of the earth. And all the other equipment is in a built environment. It's within indoors. There's nothing that's exposed to the elements. So because of that, you can expect that when you have an extreme weather event, the geothermal infrastructure will continue to operate as long as it has power, and it actually will last longer. That's another attribute of it. The reliability of the infrastructure is twice as long as something conventionally comparable because it's not exposed to the extreme elements. I mean, as we've seen, and we've all experienced across the country in different regions, the fact that climate is getting more extreme. And when climate gets more extreme, the infrastructure in the built environment has a harder time continuing to operate. And we've seen it, we've experienced, whether it's summertime events like hurricanes and storms and tornadoes, whether it's wintertime events like the polar vortexes, which have come down and hit the middle of the country, they completely disrupt the infrastructure. And that causes great cost, economic cost, and causes the loss of life and limb. And so obviously we need to build our infrastructure, create our built environment to withstand more severe climate events. When you look at trying to achieve net zero energy or zero energy capable, where effectively the facility is using net zero amounts of energy, it's not consuming anything from the grid, it's whatever it puts out, it consumes, so it's net zero. When you try to achieve that, of course, there's many different technologies that can be employed to make that happen. I think what we found, and I think the industry is finding this out, which is why geothermal is of such interest, it's very important to first reduce the energy load of the home or the building, the facility, whether it's commercial, industrial, or residential, because that has multiplicative effects down the path. If you consume less energy, then you need to offset that with less amounts of solar or other generation on site. You have to have less battery storage if you want to do energy storage. And that just means that the entire capital plant is reduced. So the very first thing we do is we reduce the energy load of the home or the building, the commercial space, with a ground source heat pump using a geothermal exchange system. And that has been shown to reduce the energy load of heating and cooling space by up to 70%. And we easily see 50% in our environment. Then we couple that with standard, very available and deployable solar photovoltaics, rooftop solar, so as we can then bring down whatever the remaining energy consumption is to whatever we want to achieve, including net zero. We can put that much solar on. And because, again, as I said, you've reduced the energy load of that home or that facility, it's much easier to be able to put the needed solar on a roof, whether it's a townhome or an apartment building or whatever, to get to that level. But the third thing I would add that is really important is the monitoring of the energy use and the whole information systems that have to support that infrastructure. And so one of the things that we do is for every single customer of ours, whether they're in a home or an apartment, we provide and instrument them with an energy monitoring system so they can take control and agency over their energy use. And we likewise can see their energy use, how their systems are operating, and be able to operate the system as efficiently as possible. The question you've asked me is, why should they do it? And I would ask, how could they not do it? Our whole way of living is moving to an electrified, decarbonized society. And in order to do that, you need to use technologies, employ technologies in the built environment that support that and don't end up either down a blind alley or in a place that's not supportable, not scalable. And certainly, if you're going to electrify everything, you need to make sure that you're efficient in how you do that electrification. Otherwise, the demands on the grids will explode, whether it's the built environment or e-mobility, electric vehicles. All of that has to be done in a very efficient way. So the question is, how can you not, if you're looking to develop a building or structure that's going to last, multiple decades, how can you afford not to put that in place now, especially when we've seen that the users of the facility, they want all of these things. They're demanding these things. They want affordable, energy efficient, low carbon, sustainable living spaces. And so the question would be, if it's available, which it is, it's scalable now, why would you not put that in place? Especially if you consider the fact that the amount of new turnover of building space is going to greatly explode or grow, doubling within the next several decades. And when you're trying to turn that amount of building stock over, you have this opportunity, you have decisions that you'll be putting in place today or in the next 5 years that will have long-term impact in terms of how the building stock will perform, over time, well into, the middle of the century. And by that time, you can only imagine the demands that are going to be placed on the grid, the need to have, as we're now fully electrified in that instance, how are you going to do that efficiently and effectively? And so you have to keep an eye to how will this asset perform, not just when you commission it, of course, but down the road. And geothermal exchange infrastructure is incredibly resilient and very reliable. It's expected to last century, a long period of time. So it's truly infrastructure worthy of the built environment. It's very resilient to any sort of worsening climate changes, which we can only expect to see occurring in that time frame. And so when you're considering turning over that building stock, you want to use technology and an infrastructure that will last, through and past the middle of the century. And that's why I think there is so much interest in geothermal infrastructure. I can't imagine there isn't any other technology that has the longevity and the resilience profile of geothermal, because as I said, it's not exposed to any outdoor environment. And so therefore it is a natural, especially with the changes that have been made to the Inflation Reduction Act, and puts geothermal on equal footing with all the other renewable technologies, both from a residential and a commercial point of view. Given all of that, it seems that you really have to ask yourself the question, why wouldn't I make that investment? I come from the solar space. So I got involved in solar in the very, very early days. And in those early days, it was fairly reasonable for an individual energy consumer, homeowner, to make the decision with a small regional solar installer provider to put that on their roof. Pretty straightforward. You can put that on the roof once the rules were designed to allow you to net metering or to interconnect. And as those costs came down, of course, that accelerated. Geothermal is different. While there are millions of homes and, of course, buildings that have deployed geothermal. I think it's well over 2 million geothermal exchange in the residential space. That decision is more difficult to make from an individual consumer point of view, because that's a large investment that has to last many, many years. And so it has been a more difficult decision for an individual consumer to make. The big change that we're seeing now is, like the work that we've done in Whisper Valley, like what EcsoSmart has done, with the networked geogrid. We're doing this at scale as a network, not an individual asset owner decision from a home, but for a facility or for a neighborhood or for a large commercial facility, where you can really benefit from a lot of the advantages that you get at scale. And I think that you're seeing not just from developers like EcsoSmart Solution doing this for new communities, but you're also seeing traditional energy utilities that are looking to redeploy their easements and maybe their natural gas distribution and redeploying that using a geothermal infrastructure for the very same reasons that at scale, the networked version of geothermal, so geothermal 2.0, if you will, that's really very scalable, and that's really where it will take off, as distinct from the more, a pedestrian type of geothermal, which was done on a one-off home by home basis, which took a long time to develop.